Okay, so this is 10.3. We're going to talk about polygons and perimeters. And we just have a couple of objectives for today. 4 as a matter of fact. What we want to be able to do is name certain polygons according to the number of sides that they have. So we'll be talking about not so much triangles, but quadrilaterals, and then four-sided figures, and then some other things. Recognize the characteristics of certain quadrilaterals. Again, just to review. Solve problems involving a polygon's perimeter. Pretty straightforward stuff. And then find the sum of the measures of a polygon's angle. And there's a nice way of sort of getting to that formula that I hope to be able to show in this video. Alright? So, what is a polygon? Alright, so polygons and perimeter. A polygon is any closed shape in the plane formed by 3 or more line segments that intersect only at their endpoints, which would be the vertex. Okay? A regular polygon has sides which are all the same length and angles of all the same measure. Most of the time when we're dealing with anything larger than a four-sided figure, we're dealing with a regular polygon where the sides are all the same and the angles are all the same. Okay, so this is the definition of a regular polygon, and you definitely want to keep this in mind. Alright, and then of course the perimeter of a polygon is the sum of the lengths of the sides. And I really like this particular definition because it doesn't take any shortcuts. It's the sum of the lengths of all the sides. You just add everything up and there you go. Okay? Now, the definition of the polygon started with, and I want to throw it back up real quick, 3 or more line segments, okay, that are connected at their endpoints. So obviously, the smallest sort of object we can have is the triangle with 3 sides. After that, we go to quadrilateral, lateral meaning side, quad meaning 4. So this is literally a 4-sided figure. Penta means 5. It's your 5-sided hexagon. Hex means 6. Heptagon, hep means 7. Octagon, octo means 8. And so literally the prefixes tell you how many sides there are. As you can tell, these are all regular because this is an equilateral triangle. All the sides and all of the angles are the same. A square is an equilateral quadrilateral. This pentagon right here, all the sides and all of the angles are the same. Same with the hexagon, the heptagon, and the octagon. Alright, now in the previous video we talked a lot about the triangle. So what we want to do now in this video is talk a little bit more about the characteristics of some quadrilaterals. Okay, so this brings us to the types of quadrilaterals that we want to focus on today. Alright, I hope I'm not making anybody sick. So the parallelogram is a quadrilateral in which both pairs of opposite sides are parallel and have the same measure, and opposite angles have the same measure. Okay, so because these sides are parallel, right, let me kind of scoot this over so it's a little bit more in the center. Because these sides are parallel, this is literally a transversal. Okay, and so because this is a transversal, these guys right here, right, are going to create an angle, and the corresponding interior angles, they're going to add up to 180 degrees, right, because this angle over here is the corresponding angles, right? So these guys are the same, so these guys are supplementary. Well, if you go around this direction, right, well, these guys are also parallel. So this is a transversal this direction, and so you end up with the same sort of thing. So these guys end up being supplementary. But if these two guys are supplementary and these two guys are supplementary, then these two guys have to be the same. And so the opposite angles of a quadrilateral are equal, and that makes us happy. It's really nice. Now, a special type of parallelogram is the rhombus. And the rhombus is a parallelogram with all sides having equal lengths. Okay, so these guys are still parallel this direction. These guys are still parallel this direction. So these opposite angles are equal, and these opposite angles are equal. Alright, but what happens is all of the sides are the same. Rectangle, parallelogram with 4 right angles. So now all of the angles are the same. Square, rectangle with all sides the same length and all the angles are the same. So this is our regular quadrilateral. Okay, our regular quadrilateral. Okay, so the square is the regular quadrilateral. Alright, so let's bring it up. Where all of the sides are the same and all of the angles are the same. Now you'll notice that all of the opposite sides are the same, all of the opposite sides are parallel, all the opposite sides are parallel, all the opposite sides are parallel the same, all of the opposite sides are parallel the same. So for these 4 figures, the opposite sides are always parallel and the same length. This is not true for the trapezoid. This is the only one where the quadrilateral only has 1 pair of parallel sides. And so this is an isosceles where these 2 guys are still the same length. But the opposite sides here are not parallel. And so that's a trapezoid, and that's the big difference. And that makes us happy. Alright? So now we want to do an application of perimeter. Now, we had perimeter, okay, as part of our definitions. So I want to put that back up. Remember, I told you it's the sum of the lengths of the sides. And I told you I really like that because that applies to everything, right? So I'm looking at fencing that cost $5.25 per foot, and find the cost to enclose the field with the fencing, okay? And now the field is 42 yards by 28 yards. But we're looking at this and I'm thinking, this looks a lot like a rectangle. So that means the opposite sides are going to be the same. So while this here is 28 yards, okay, and I'm going to add, right, because it's the sum, the 42 yards, okay, and then this side right here is opposite the 28, so that's going to be 28 yards, and then the opposite side over here is the 42, and so you're going to have 42 yards. Now, yes, there is a formula for the perimeter of a rectangle, but I really want to reinforce that it's the sum of all the sides for rectangular objects. And so when I add these up in my Henda calculator, right, so we're going to put 42 plus 28 plus 42 plus 28 and hit enter. I get 140. So I'm going to end up with 140 yards. But now my fencing is per foot. Man, I need to know how many feet that is. Well, if 1 yard is equal to 3 feet, then the multiplier is times 3. 1 times 3 is 3, so I need to take the 140 yards and multiply it by 3 to convert it to feet. And so now I'm going to pull out my handy dandy calculator, and I take 140 times 3, and I hit enter, and I get 420. So I have 420 feet. Well, if you have 420 feet, and you're going to spend $5.25 per foot, then you need to multiply those together. And so I'm going to take 420 times 525 and get $2,205. So $2,205 is the cost there. And so this makes us happy, right? So the perimeter is the length around. 1 to 3 is the conversion factor. That gets me into feet. I multiply the number of feet by the cost per foot, and that gives me the total cost right there. And that makes us happy. Okay? Now, they actually give you the formula here for the polygon angles. The sum of the measure of the angles of a polygon with n sides is n minus 2 times 180. And really the reason this is, and I just want to show it real quick, right, is because we've got a triangle, and I know that a triangle has 180 degrees in it. And then I've got a square, and I know a square with all those 90-degree angles in there is 360 degrees. I look and I go, well, this is 3 sides, and I got 180, and this is 4 sides, and I got another 180. Wondering if this pattern holds. If I went to a pentagon with 5 sides, what would be the length, the sum of all the interior angles? Well, 180 plus 180 is 360. 360 plus 180 is 540. And it turns out that there is 540 degrees in there. So if I take 3 and I minus 2 from it, I get 180 degree. If I take 4 minus 2 in it, right, I get 180 degrees, which gives me 360. And if I take 5 minus 2, that gives me 3, and 3 180s give me 540. So this is the way that we build this formula up, all right? Because math is the study of patterns. So now, if I want to find the sum of the measures of the angles in an octagon, well, octo means 8, so my n is 8 here. And so, actually, I can just put this straight into my calculator, right? I mean, I don't even have to do... Whoop, I knocked my camera over. All right, so parenthesis 8 minus 2, right, times 180, and I'm going to have 1080 is my total there. So the total is 1080 degrees. All right. Now, if this is a regular octagon, if it's a regular octagon, then all the angle measures are the same. I'm going to take this and I'm going to divide it by the 8 sides. And if I divide that by the 8 sides of my calculator, I get 135 degrees per angle on the inside. All right. This concludes the lesson, and see you for the next video, and that makes us happy.